Okay, everyone, we're going to do our sixth lesson in this unit and the last one in this unit, all about mixed and entire radicals. So we started talking last time about irrational numbers and all those number systems and how we could write a number from exponential form into a radical format. But now we got to talk about what happens if there's different forms of radicals. And then we can convert back and forth between the two. So the two types of radicals that we're going to deal with, either an entire radical or a mixed radical. Now the difference basically is explained in this little box here. So you've got two radicals in there. The one that's called an entire radical, those are the ones you're going to see that don't necessarily have a coefficient on the outside of the root sign, okay, or that radical symbol. And we learned last time that we have what's called an index, and that will always tell us what type of radical it is. And since we don't see that number on the outside of that symbol, we assume as a society that this is a square root. Okay, the number that's underneath is called the radicand, and the number that we don't see there is the coefficient. Now, compare that to a mixed radical, where now I do actually have a coefficient. So we're going to use some of those words to talk about these few examples we're going to do. Now there are a lot, so I won't do all of them, but I will give you the full answer key in the description box underneath where you can try them on your own and see how you did. So the way that we can do this is, if you're working with radicals, you can rewrite an entire radical as a product of two radicals. So when you go to actually multiply some root signs together, as long as the index is the same, and you have, for example, something like the square root of x multiplied with the square root of y, if you've got the same index but two different radicands and you multiply, what you get is the square root of x multiplied with y. So we can actually split up those radicands and that radical into two parts to make this a little bit easier for us. And the way that we're going to split them is we're going to factor essentially the radicand so that it's a perfect square multiplied with some other number. Okay, so if it's a square root, obviously we're looking for perfect squares. If it's a cube root, perfect cubes, so on and so on. Let's make that a little bigger for us. So if we start by looking at A, 45 is our radicand, and it is a square root. So when we go to break that up into the product of two radicals, we want the radicands that are underneath, one of them to be a perfect square, one of them to be something else that when you multiply them together, you get 45. And one of the ways, or the way that works for us, is 9 multiplied with 5. The product of 9 and 5 is 45. 9 is a perfect square, which is great. So we can go to simplify this by actually taking the square root of 9, telling us it's 3, and then we still have our square root of 5 left that's being multiplied with that square root of 9. Okay, so 3 roots, that is a 5. And what you've just done is taken an entire radical, now rewrote it as a mixed radical with the coefficient and the radicand inside that we can't do anything with. So we can double check on our calculator to make sure our forms are equivalent. And we can say that the square root of 45 equals, and then 3 square root 5 equals. If we get the exact same thing, we know our forms are equivalent, which we did, and we're okay, we're good. Okay, let's try another one. Let's try B, so square root 75. Approach it the same way. We want to have the product of two radicals, one of those things a perfect square. And if you think about 75, the biggest one that will work is 25, and you're going to multiply that by 3. So 3 times 25 will give us 75. And the reason why I say that it should be the biggest, if you don't choose the biggest perfect square first, you might have to do this step again, and we'll see that in a couple other examples if we don't pick that largest one first. But if I square root 25, we get 5, and this ends up being, oops, I don't want that there. This ends up being a square root 3 that gets multiplied. So essentially, that perfect square becomes the coefficient of the leftover part of the radical, which didn't make up our perfect square. So 5 root 3 and root 75 are identical. I'm not going to do C, but it's very similar to A and B. I'm going to try to do E instead for us. that is a little different because now we have a cube root to think about. So if you're going to approach this, you still want to make sure that it's the product of two radicals, but this time you can't forget your index you started with was 3. So that index has to get carried throughout the entire problem. So this time we're not looking for a perfect square, we're looking for a perfect cube factor of 144. Okay, and one of those perfect cube factors that will work for us is 8. And if you're forgetting what your perfect cubes or your perfect squares are, a couple videos ago we made a chart that had the list of the first 15 perfect squares and the first 10 perfect cubes. You can look back at that or just Google the new chart. And now the other number that's left over, so 144 divided by 8 is 18. Okay, so we're actually going to compute the cube root of 8. That's going to give us 2. And it's going to be multiplied with the cube root of 18. So we've wrote it now as a mixed radical. And we can again double check. So math 4, 144. And then 2 multiplied with the cube root of 18. And we do get the exact same result. So we know that our forms are equal. Okay, so I'm going to leave all the other ones. Now for I, when you would attempt it, and H, just remember that it's a 4th root. So you're looking for the 4th root here. So something multiplied by itself 4 times to give that result. So think about that one. It might be a little tricky. So try that one out and check the answer. So for example, 2, we're going to go backwards. And we're going to try to take something that already is a mixed radical. And we're going to write it as, you know, an entire radical with no coefficient. And what we're going to do is we're going to rewrite that coefficient of that radical as a radical of a perfect square. So think about how we went, for example, 1 and kind of broke it into 2 parts. We're going to try to do something similar and place the 2 parts back together. So the coefficient, and maybe I'll change colors here. Our coefficient will go under one of the root signs, and our root 7 will go under the other one. Now, when we do deal with this coefficient, right now it's on the outside of a root sign. If I go to place it underneath, I have to make sure I use that index as its exponent. So if this is a square root, I'm basically just going to take the coefficient and square it when I put it underneath. So this is technically 5 squared. And my 7 that was already underneath my root sign will stay underneath my root sign. Okay, so the 5 squared is going to become 25. The 7 stays. Now, before, we basically square rooted and we were done. Now we're going backwards to the other direction. We want to make sure we put these 2 radicals together. So we're going to take the 2 radicands, the 25 and the 7, and we're going to multiply them together to really show they're going underneath the same root sign. We're actually putting them together. So the square root of 175 is equivalent to 5 root 7. So we'll show you that as well. Okay, so 5 square root 7. So there you go, equal formats. So again, just keeping that calculator handy and double checking as you go, a really good way to make sure that each of your forms is actually equal. Okay. If we think about B, B just has a fraction. It really is no different. So if we go to approach that one, and maybe I'll move this calculator over a little bit, give me a little space to write. Okay, so equals. We'll keep our coefficients in red. So I'm going to have a root sign, but it's going to be 1 over 2 squared. Okay, and then our other root sign will have our root 10. Now when we take 1/2 and we square it, we're going to get 1 over 4. Okay, there's my root 10. Now, when we put those 2 fractions together, the two radicands together, 1 over 4 multiplied with 1 over 10. You can do that in your calculator as well. 1 over 4 multiplied by 10 gives you a decimal. We can turn it into a fraction by pressing math 1 and enter. Okay, so our simplified fraction is 5 over 2. Really, it should be 10 over 4. So So this 5 over 2 is just the lowest form of that. Okay. I'm actually not going to use 5 over 2. I actually want to use 10 over 4 here and not reduce it, because there's one last thing I can do to actually simplify this. So when we go to take the square root of a fraction, it's really like saying it's that fraction to the power of 1/2, which we looked at last time. So I can actually take the square root of the top and then the square root of the bottom. So as a final kind of simplifying step, shrink that a little. As a final simplifying step, I could actually take the square root of the top, the square root of the bottom. Now, the square root of 4 is actually 2. So I want this to be the square root of 10 over 2, which is basically identical. What the calculator did is just reduce it first, and I'd be taking the square root of the whole thing, which is the same exact result. So if I did the square root of 10, divided it by 2, I get 1.58 something. So if I do, let's change it to 0.5 square root 10. Okay, exact same thing. Okay, no different. But now everything's kind of combined and really nice. So technically, this is my entire radical format. This is just another way to kind of simplify to say that I can actually take the square root of the bottom. So if you're going to leave it as an entire radical, this is the one you want in that red box because there's no coefficient. So that one would actually be that 5 root 2 or 5 over 2. That's where it's coming from. If we keep going and simplify like I did, essentially it's the exact same form as the first one, just with the 2 written as a fraction underneath. So you can simplify it that way, and then you get into your infinite circle loop. If you're asked for that entire radical, this is it right there. So that's your entire. It depends on the context you're asked, so be very careful of what your question is. Okay, all of the other ones are going to work the same. So I'm just going to pick one of the ones with a different index, and we'll do h here. So we're going to try to do this with the basis of cubes. So we need to have 2 radicals with an index of 3. Now our coefficient, once I place it from the outside of that radical to the inside, the index gets applied to it as an exponent. So since this is a cube root, we're going to cube that coefficient. So 2 cubed. The one that was underneath the root sign stays. Okay. So when we go to do this, it's a cube root of 8 multiplied with the cube root of 4. Those radicands will get multiplied together and go under the same root sign. So 8 times 4 will give us 32. Okay, so there it is as an entire radical with a coefficient of 1 on the outside. Okay, so there's how we can go back and forth between them. Now, if we take a look at some of the other ones, what happens if there's already a coefficient there and we're asked to write this in lowest term mixed form? So we want to take this mixed radical and make it a lower mixed radical. We want the radicand to be as low as possible. So if we look at A, we're basically already with a mixed form. I have a coefficient and I have a radicand. So what we're going to do is actually kind of break this up a bit. Okay, so I really didn't change anything, just represented a dot for that multiplication, really split it up. Now we're going to deal with that root 18, and we're going to break that into 2 radicals, just like we did in our first example. So the root 18 can be split up into square root 9 multiplied with square root 2, since 9 times 2 is 18. But I chose 9 very deliberately because it's a perfect square. So you can square root it now, 4 times 3, and then multiply it by 2. And here's where I get a new factor being put into our coefficient. So our new coefficient ends up being 12 square root 2. So this would be considered the lowest form mixed radical because that radicand is as low as possible. It's much lower than 18, Both forms are equal. However, this is the much simpler format because the radicand is simpler. So it's just a matter of breaking that radical down as far as possible and combining our coefficients. Okay? So we could do that same thing for, let's do E here. So I've got a -3. We've got a cube root 16. So again, -3 is your coefficient currently. 3 as our index. So cube root 16. So let's break that up as well. So we need a perfect cube factor of 16. And the perfect cube that will do it is 8. 2 is the other remaining number. So the cube root of 8 is 2. And cube root of 2, I can't do anything with or reduce, so it stays. Now I can multiply those two numbers together for my coefficient, remembering that I have a negative. So -3 times 2 is that -6. Okay, so -6 cube root 2. And there it is as our reduced simplified form. So all of these other ones, very much the same. Find that perfect square number or find that perfect cube number and reduce from there. Now, example 4, I don't really like to do because you're always going to have a calculator anyways. So if you want to attempt them, basically what you're going to do is order them from least to greatest, no calculator. So you're going to try to make sure that you compare the radicands to do this. Okay, so if the radicands and the indexes are the same, then you can compare them very, very easily based on size. So I'm not even going to do this one because you can type them all into your calculator anyway. It seems like a little bit of a waste of time. So I will give you the order. That way, if you try them, you can always compare to make sure that you have the same order. And that takes us right to the end of our lesson here. So this was a short one. So again, if that helps, wonderful. And again, please get in touch with your teachers, get in touch with me if you need a little bit of assistance as well. I'll be more than happy to help. So if you're looking for the answers to any of these questions, that link will be in the description down below. So our next unit, which we'll talk about, is polynomials. So we should take and remember all of the stuff from exponents because that's always going to come back in there as well. So thanks for watching, and we'll see you next time.